This is my digital logic design final project. It's a secret knock lock. Only specific knock will unlock this box and you can open it. Everything was done using logic chips, 10 chips in total, not a single microcontroller inside. And I'm using a solenoid over here, which I put a weak spring that I found inside of a pen, so that when you can push it and when it comes out, so it's really normally open. So now I'm going to do the secret knock that's programmed inside. So now this opens, and now I can open the box and see whatever I want inside. And you can see this thing came back out. I can also program it by flipping this switch over here. This puts it in programming mode. So as you can see, that light turns on, and now I can program whatever I want. So for example, I'm going to program a new tone. This time it'll just be 2 knocks. So that's the new tone. And now I take it out of programming mode, and I'm closing it up again, and now I can do my secret knock that I just programmed, and that's that. And I can do whatever knock I want. So let's do something a little bit more complicated. Flip this on. The real difficulty is making your knock the same each time. So let me program something a little bit easier. Something more difficult. It's out of programming mode now. I locked it back up. Can't open it. Now let's try the new secret knock. So you see there's an error. I didn't do it the exact same thing. Let me try one more time. So that's my lock. And now I'll show you what happens if you do the wrong tone. So all these times I was doing the correct tones. So that before was the correct tone. Now obviously this is going to be wrong. Just a single knock. That's obviously wrong. So see the error light turns on. Or let's say a sequence 1, 2. So that's also wrong. Or something else that's not exactly the knock. It's also wrong. Then again, if I do the secret knock, let's see if I get it right this time. Oh, I got it wrong. There we go. It opens. So really the trick is practicing your knocks to get it the exact same tempo. Because what this does is it takes that 2-second knock and splits it up into 8 bits and then checks to see if the new knock matches those 8 bits. So you really just need to be very careful to make sure you have the exact tempo each time. It's good to have timing in your head of these things. So here's just a closer look. There's the EEPROM, the programming switch, and here I have a bunch of flip-flops, counters. I did a lot of tricks on the circuit to help minimize space. For example, instead of using an inverter, I used a XOR gate with just one pin going straight to 5-volt power and the other pin going to the thing that I wanted inverted. So that was an inverter. And I ran out of AND gates at one point, so I used a leftover flip-flop gate. And there's just a whole bunch of these space-saving things. And perhaps the most innovative or space-saving thing was that the way I'm using the EEPROM is I'm only actually using one pin, not all 8 pins. And instead of muxing whatever inputs I get and then just checking it bit by bit, pin by pin, instead I'm actually changing the address of the